In today's video, we'll be going through both arithmetic and geometric sequences, which are both finite, and we will also be using the summation formulas. Well, to start off, let's go through our base equations. Well, for an arithmetic finite type of question, we're going to be using s subscript n equals n over 2, parentheses a subscript 1 plus a subscript n. Or we could also use s subscript n equals n over 2, parentheses s parentheses 2 times a subscript 1 plus n minus 1 times d. And here you can see the main difference is that you have a d, which is, again, if you watched our last video over arithmetic and geometric sequences, our d just represents our common difference. Next, going on to our geometric sequences, we have the equation s of n, or s subscript n, equals a1 times 1 minus r to the power of n over 1 minus r. Well, now let's go ahead and do some practice problems using these equations. The first practice problem is asking us to find the sum, and it gives us this type of question. Well, you might be asking, what is this? Well, this is what you call summation form. This symbol right here is called sigma, and sigma is just representing that you need the sum of the values. And you can see that we have some type of equation here, and we have numbers here and here. This number down here is representing the number that you are starting at. So your starting value, and this is telling you how far you want to get in the sequence. Now, let's go ahead and do this problem. Well, in this type of problem, what we do is we first take this bottom number, which says g equals 4, and we're going to substitute that value into this equation. So we have, let's do it in a different color, we have 5 times 4 plus 3. Well, 5 times 4 is 20. 20 plus 3 is 23. So we know when that g equals 4, it's 23. We need to get to the 9th term. This is our 4th term. So let's write this here. 4th term is 23. Now we need to get 9, and then we need to take the sum of all those numbers. So our 5th term is going to be 5 times 5. 5 times 5 plus 3. 5 times 5 plus 3 is just 28. So we can go 5th is 28. And you can see they're just increasing by 5. Let's go ahead and keep adding 5. So 6th is going to be 33. 7th is going to be 38. 8th is going to be 43. And finally, 9th is going to be 48. Now let's go ahead and add all these numbers together. So we have 23 plus 28 plus 33 plus 38, 43, and 48. Once adding all these numbers together, we should get a grand total of 213. And that is going to be our answer for number 1. Same concept for number 2. We're going to do the same thing. Well, here you can see we're starting at 0. So our first value in our equation or in our sequence is going to be 0. We have 0, negative 2 times 0 plus 5. Negative 2 times 0 is just 0 plus 5. So we have 5. And then our next value is going to be 1. So 1 times negative 2 is negative 2. Negative 2 plus 5 is negative 3. And then we're going to our 4th value. So we need 3 more values. So now we have, this is our 0th value. This is our 1st value. Then we have to substitute in our 2. Negative 2 times 2 is negative 4. Negative 4 plus 5 is 1. That's our 2nd value. 3rd value, well, 3. Now we're doing the 3rd value. So 3 times negative 2, which is negative 6. Negative 6 plus 5 is negative 1. That's going to be a 3. And then our 3rd value is going to be negative 1. Then we have 4th value. 4 times negative 2 is negative 8. Negative 8 plus 3 is negative 3. And that is it. Now we take the sum of all these numbers. And so we have 8 here. 8 plus 1 minus 3. 9 minus 4. 9 minus 4 is 5. And our grand total and our answer for number 2 is 5. If you do have an end star, you can press menu 4, 3, and then it'll give you a summation. And you can just substitute in your values and get the answer in a minute. Now let's go ahead and do our second type of problem, which says that we must rewrite using summation notation. As I said before, the questions we just did in 1 or 2 are already in summation notation. And in number 3, it's giving us a sequence, and we just have to input it into summation notation. Let's go ahead and do that down here. Well, we know that the number on top of our summation, or our sigma, so the number on top of our sigma is how many numbers we have in the sequence, or how far we're going in the sequence. So you can see that we have 1, 2, 3, 4, 5 numbers here. So 5 is going on top. We have 5 on top. And then the bottom is what we're starting at. In this type of scenario, I'm just going to say we're starting at 1. So we're going to do x equals 1. And now in order to find the value that goes right here, or the equation after our sigma, what we're going to do is we're going to use the equations we talked about at the beginning of this video. So first, we need to figure out if this is a geometric or a arithmetic sequence. Well, we can see from 8 to 11, we have a common difference of 3. 11, 14, 3. 14 to 17, 3, and 17 to 23. So we can see that we're only adding 3 each time, which means it's an arithmetic sequence. If we were multiplying, it would have become geometric. And if we're adding, it has to be the same number each time that's getting added to the previous number. And in this scenario, that is 3. So the 3 is our d value. And in order to solve this type of problem, you really need to know how to use arithmetic sequence equations. And the arithmetic sequence equation, you'll learn how to use it in our last video, which will be in the card up above. And the arithmetic sequence equation is a subscript n equals a1 plus n minus 1 times d. And here, we're just going to be solving for our equation. Well, we know that a of n equals a1, which is 8, plus n minus 1 times our d value, which is 3. Let's go ahead and distribute the 3. So we have 8 plus 3n minus 3. 8 minus 3 combined like terms. 8 minus 3 is 5 plus 3n, and that is our equation. Let's go ahead and put that right here. 3n plus 5. Well, we can see that our main variable is x. So we're going to, instead of n, we're going to say x. Just to keep it simple. 3x plus 5. And then that's going to be our answer for number 3. In this next type of problem, what we're going to do is we're just going to use our formula and we're going to expand. So we're going to have a sequence something like this, and we're just going to find the sum. And in order to do that, what we're going to do is we're going to substitute in our values. So we can see that we're starting at an n value of 0, and we're going to go as far as our 6th term. Well, we have 1,000 times 1/2 to the power of 0. Anything to the power of 0 is 1, so we have 1,000 times 1. 1,000 times 1 is just 1,000. So we have 1,000. So that's our 0th term. Let's go ahead and find our first term. So we have 1/2 to the power of 1, so 1/2 to the power of 1 times 1,000 equals 500, because 1/2 to the power of 1 is just 1/2 times 1,000 is just going to give us half of 1,000, which is 500. So we have 500, which is our second term. Third term, so now we have 1/2 to the power of 3. 1/2 to the power of 3 just equals 1/8. 1/8 times 1,000 is just 125. That's our third term. Now let's go ahead and get our fourth term. So we have 1/2 to the power of 4 equals 1/16 times 1,000 equals 125/2 equals 125/2. So fourth term is 125/2. Which is just about 62.5, but we're going to leave it in fraction form just to be a little more exact. Next, let's go to our fifth term. So we have 1/2 to the power of 5, which is just 1/32 times 1,000, which will give us 125/4. 125/4 is our fifth term. And finally, let's get our sixth term. And our sixth term is going to be 1/2 to the power of 6, which is just 1/64. Times 1,000, and we should get 125/8. Well, now we take the sum of all these values, we should get a grand total of 15,875/8. And that is our answer for this fifth question. Now for number 6, finally, well, for this type of question, we're going to be using the geometric sequence formula, which is a subscript n equals a1 times r to the power of n minus 1. And then we're going to be using the sum formula for a geometric series. We know that a subscript n equals 2470629. This is this last term right here. And that equals our a1 value, which is 3/7, equals 3/7 times, and we can see that going from 3/7 to 3, we're multiplying by 7. 3 to 21, multiplying by 7. 21 to 147, multiplying by 7. So we can see our r value is 7 because we keep multiplying by 7 in order to get our next value. So we have 7 to the power of n minus 1. Well, now we just solve for our n value. what we do here is we multiply both sides by the reciprocal of this. We just need to get rid of that value from our right side and bring it to our left side. Well, what we do is multiply by 7 over 3, and that goes to 1. 1 times any number is itself. So 7 over 3 times 2470629, which is this value right here. And that gives us a value of 1058841. And this just equals, so since we got rid of this, it's eliminated. We have 7 to the power of n minus 1. Now, in order to get rid of this base, because it has an exponent, it's called a base, we're going to take the log. So we take log base of 7, because that's the number we're eliminating. Log base 7 of 1058841. And we do the same thing on our right side, equals log base 7 of 7 to the power of n minus 1. So we're left with n minus 1 on our right side as log base 7, and 7 eliminate because log base 7 and 7 eliminate each other. And log base 7 of 1058884 is 7.12915. And now all we have to do is add 1 to both sides. So we're left with 8.12915. And that is our answer. I hope this video helped. If you believe it did, please consider like and subscribe. It would greatly be appreciated. Please check out the Instagram for future video updates. Thank you.